Question 1. Explain the meaning of differentiation and what are the techniques of differentiation. The meaning of differentiation. Differentiation is the mathematical process of finding the derivative of a function which measures the instantaneous rate of change of one quantity with respect to another. Differentiation technique. First, constant rule. The derivative of a constant is 0. Second, power rule. The derivative of a power function is found by bringing the exponent down as a coefficient and reducing the exponent by 1. Chain rule. The chain rule is used to differentiate composite function, which is a function within a function. Fourth, product rule. The product rule is used to find the derivative of a function that is the product of two other functions. Fifth, quotient rule. The quotient rule is a method used to find the derivative of a function that is the ratio of two other differentiable functions. 6. Constant multiple rule. The constant multiple rule states that the derivative of a constant multiplied by a function is the constant multiplied by the derivative of the function.
So for the question 2, it asks us to find dy dx for the following functions. So for the first functions, it was y equals to 2x squared e sine 3x. So to solve this, we need to use product rules. What are product rules? Product rules are u v prime plus with v u prime. So we need to classify which one is u, which one is v, which one is u prime, and which one is v prime. So as we know, 2x squared are u and e sine 3x are v. So to find the dy dx, we will find the prime first. Okay, so for the u prime, 2 multiplied with 2x power of 2 minus 1, so it became 4x. And then for the v prime, e sine 3x will multiply with 3 cos 3x. And why we multiply with the cos? Because when we look into the derivative table, it asks us to change the sign to be a cos. Okay, and then we can find the dy dx. So 2x squared multiply with e sine 3x cos 3x, and then plus with e sine 3x multiply with 4x, and the answers will be 6x squared cos 3x e sine 3x plus 4x e sine 3x. So this is the final answers. So for the second functions, it was y equals to 3x squared minus 1 divided to sine x. Okay, so for solve these functions, we need to use quotient rules. Okay, what are quotient rules? Quotient rules are v u prime minus u v prime divided to v squared. Okay, so we need to find the v, the u, the v prime, the u prime. Okay, so what are the v? Okay, the v are sine x and the u are 3x squared minus 1. And then we will find the prime for v and u. Okay, so for prime v, it will become cos x, and for the u prime, it will become 6x. Okay, and then we use this quotient rule to solve the questions. Okay, so dy dx equals to v 3x squared minus 1 multiply with 6x. 3x squared minus 1 multiply with cos x minus with sine x multiply with 6x. So, and divide with sine x squared. And then it will become 6x sine x minus with 3x squared minus 1 cos x divided to sine square x. So this is the final answer.
For question 3, first we will need to differentiate both sides before differentiate for each term. For term 1, it requires the product rule and chain rule. So we will get u equals to x squared, u prime to x, v e for x plus y, and lastly v prime is for e for xy times 4x plus y. We will need to replace the y with dy dx, so we will get e 4x plus y times 4 plus dy dx. For term 2, we'll differentiate sine square 3x using chain rule. So we will get 2 sine 3x, cos 3x, and 3. Then we solve it, and the final answer for term 2 is 6 sine 3x cos 3x. For the last term, term 3, ln y square, we differentiate it and we will get 2 dy dx over y. Lastly, we substitute all the answer that we differentiate earlier, then we combine dy dx to the left side and the rest on the right side. On the left side, we factorize dy dx and rewrite the equation on the right side. Then we solve it. After that, we can leave this as our final answer, or you can take out the y by multiply it with y. Then we got the answer for question 3.
Lastly, question 4. Use linear approximation to estimate the value of cube root 63.99 plus 1 per square root 63.99, correct to 3 decimal places. First, in this question, we need to use a linear approximation formula. A linear approximation formula is fx equal to fx0 is the norm point plus f prime x0 is the slope, and time with the small change in x. We also need to choose a nearby point and calculate the small change in x. The formula for the small change in x is x minus with x0. How to solve this question? First, we need to define the function and the points. Cube root x plus 1 per square root x, we need to change to x 1 per 3 plus x negative 1 per 2. Second, we need to choose the nearby point, which is x0. We choose x0 equal to 64 since cube root 64 equal to 4 and square root 64 equal to 8. After that, we need to calculate the differential. The formula for differential is x minus x0. X is 63.99 minus x0 is 64. We get negative 0.01. Step 2. We need to calculate the necessary components. Firstly, find the derivative f prime x using the power rule. Firstly, we need to bring the power to the front and the power will minus 1. So we get 1 per 3x negative 2 per 3. Same goes to this one. The power will go to the front times with x and the power will minus 1. So we get negative 1 per 2x negative 3 per 2. Lastly, the answer is 1 per 3x 2 per 3 because when we bring the negative power to here, we get a positive numbers. So we get 1 per 3x 2 per 3 minus 1 per 2x 3 per 2. Second, we need to evaluate fx0 at x0, which is 64, into the d per dx, which is this one, into this. So we get the answer is 33 per 8. After that, we need to evaluate f prime x at x0, which is 64, into the f prime x. So after we calculate, we get 61 per 3072. Step 3, which is the last step, we need to apply the linear approximation formula. This one is 63.99, this one is 64, and this is 64, times with this, which is negative 0.01. So we get 30 per 8 plus 61 per 3072 times with negative 0.01, and the final answer is 4.125. This is the final answer.